once again entirely. The simple circuit with one switch, two switches in series connection. So P is the statement corresponding to the switch S1 and Q is the statement corresponding to the switch S2. And you have to denote it as the switch S1 is closed, S2 is closed. Now, if it is asked, write the input-output table means use true and false. If it is asked switching table means use 1 and 0. Now, here the current flows in the circuit and the lamp will glow only when both the switches are closed. That means if P is true and Q is true, then only the P and Q, that will be what? True. That means the lamp will glow only when both the switches are closed. So this corresponds to the compound statement conjunction. So when the two switches are connected in parallel, under what conditions of the switches the lamp will glow?
Any one or both switches are closed.
If any one of the switch is closed or both the switches are closed, then the lamp will always glow. And the lamp will not glow only when both the switches are what? Open. That means this switch circuit corresponds to which logical compound statement?
Disjunction.
That is disjunction. P, R, Q. Now write the input-output table. So when P is true, Q is true, means both the switches are closed. Then the light will glow. That means true. Now, if the switch S1 is closed and S2 is open, still the current flows. When switch S1 is open and S2 is closed, still the current flows. Now, when both the switches are open, the current will not flow and light will not glow. It will be false. So remember, parallel connection corresponds to disjunction and series connection corresponds to conjunction. Complementary switches. Complementary switches. Two switches, S and S dash. Two switches, S and S dash are said to be complementary. Two switches, S and S dash are said to be complementary if one switch is open, then the other will be closed. Two switches, S and S dash, are said to be complementary switches. If one switch is closed, then the other will be open. The corresponding statements must be taken as P and negation of P. The corresponding statement must be taken as P and negation of P. So if S is closed, then the statement P will be what? True. Then S dash will be open. Then the negation of P will be what? False. If S is open, then the statement P will be what? False. Then S dash will be what? Closed. The negation of P will be what? True. So whenever any circuit is given, so logically you should be able to express in terms of the statements, and you have to write the corresponding truth values, and you have to give the conclusion. That is when the lamp will glow and when the lamp will not glow. So calculating the negation of the compound statement is very, very important. Now, so this simplification will be useful in the circuits. So for a given circuit, we are expressing the corresponding logical statement, that is a compound statement, and using the properties of algebra statement, we are simplifying to another form, and then you are constructing a circuit. Now, in the initial circuit, how many switches you have used?
5.
5. But after simplification, how many switches are required? Only 3. That is what is going to happen in the electronics. Now, previously when you observe the TV, it will be a very, very large one. And now it becomes a very thin one. And wherever possibility is there, the circuits are becoming very, very small, because you are go on changing to the new form. For each statement, when you are simplifying, you are trying the corresponding statement which you are using. That explanation is very important in this.